Okay, good morning. Uh, Good afternoon. In the previous class, we have completed the process and the threads. How the process and thread will be, what are the primitives of processes and the threads have been it's completed in the previous class. And today, I'd like to go ahead with the second concept of unit number 2, that is interprocess communication. So, what are the different aspects which are being involved in interprocess communication, and a brief explanation regarding to each and everything, and followed by an extensive and enlarged explanation for semaphore. Of course, semaphore has not been taken into consideration by today. Tomorrow we shall take semaphore and its activity. How semaphore is being implemented will be taken in the next session. Okay. Now, today we'd like to concentrate on first thing. So, interprocess communication. Actually, what is the interprocess communication here? Interprocess communication will allows to communicate each and every, not each and every, communicate one process to another. One process to another, it is being communicated, and it is not actually in the concurrent system purview. It is in the operating system purview. Okay, it is in the operating system purview. Even then, whatever the operations which have been done in the concurrent system, the same kind of activities or operations are being done by this interprocess communication. So that is why this particular concept is there with you. Okay. Normally, interprocess communication will always concentrated accessing of data and modification of data, and message is being processed, or message is being forwarded to one process to another process. These are the three aspects which are mainly involved in interprocess communication. And normally, interprocess communication could be happen in single user system and multi-user system, and parallel and distributed computing systems also. Okay, it could be happen in everywhere. So single user system, if you consider single user system, so more number of processes will be executed with one particular system. Therefore, interprocess communication could be gets happen, but the level of interprocess communication system in terms of single user system is very less, because no other process or no other foreign process is not there with that particular system. Therefore, there is no level of application level of interprocess IPC cannot be that much huge in terms of single user system. Whereas in multi-user system, let me say, what do you mean by multi-user here in the sense? On network, there are many number of systems, and if any event is gets operated on network, how that is being handled. So that could be considered as a network-based system. Thereby, interprocess communication could be gets happen in an extensive way. Of course, so let me say then for some 40 to 45% of interprocess communication activities will be there in multi-user system. If you go in the next level of multi-user system, that is parallel processing. So completely parallel processing depends upon IPC, interprocess communication only. And if you go for distributed, it is 100% IPC only, interprocess communication only. Okay. However, so the level of application of IPC, interprocess communication, will be gets improved right away from single user system to distributed system onwards. So therefore, this communication, whatever the communication we have been taken here, that communication will be let another process will be take some event which has been occurred to transfer the data and process the data between one process to another process or among several number of processes. So this is the basic idea regarding to inter-process communication. And what kind of approaches have been developed so far while inter-process communication system is being happening in either operating system or parallel processing system. Of course, as I said just before a couple of minutes ago, so inter-process IPC has been available with operating system, okay, with operating system only. Then what are the different approaches have been taken into consideration or taken into account to process the inter-process communication? First and foremost will be the pipe. So as we have operated this particular pipe in MS DOS or Unix shell or somewhere else, let me say, so in Unix shell, you may be taken ls-l. If you take this particular command, it maybe gives you long listing of all files which are available within that particular directory. Okay. If number of files will be very huge, I mean too many number of files are there, you cannot see these too many number of files within single screen. So therefore, you have been operated one particular pipe here, one particular pipe followed by one more command, that is more. If you take this particular command, obviously whatever the data you have been created or you have been generated by this particular command, it will be forwarded to this particular pipe, and after completion of forwarding of this particular data from ls-l, it has been taken. So right away from here to here, and more will be gets displayed. So finally, the conclusion for pipe will be it is unidirectional. Unidirectional in the sense, let us consider. So if you consider this is the pipe here, you are trying to write onto the pipe right away from one end, and we are trying to take the data from this particular pipe in another end. So let us consider this is writing end and this is reading end. So if you take something like this, data will be processed or data will be flow in this direction. Okay, it is always unidirectional. It should not be multi-directional, or so it should not be. So write and read operations cannot be done in either ways. Only one way. So as far as the program which is being implemented in network programming, Unix and network programming kind of laboratories, you may create some file descriptors 0, file descriptor 1. File descriptor 0 is always responsible for writing. File descriptor 1 is always responsible to read the data from the pipe here. However, this is not the time to be discussed what exactly the implementations of this pipe here. So I'm giving some very precise information to you people. Okay. So simply speaking, pipe in the sense it is a temporary buffer which has been created in kernel. Probably that is not there in the in this explanation. It is a temporary area, temporary buffer. It is actually buffer. So which is being created at a kernel, not exactly with user. Okay, there is a huge difference between kernel and the kernel area and user area. Kernel area is completely temporary, volatile. Soon power has been left from the system. Kernel area or buffer area kind of storage will be immediately vanished and could not be available anymore. Whereas if you take the same thing in terms of hard disk drives or floppies or pen drives, it's not something they will be available. Even power contents will not be there with that system. So that is why it is a temporary buffer area. Basic size of this buffer will be 64 megabytes. So whatever the data you have to send, so everything will be placed into that particular buffer and then processed by some other command or some other process. Let us consider this is one process. As far as Unix operating system, it is one process, and this is another process. These are the two different processes taking input from the buffer, not actually from the ls-l. Directly it could not be taken. Since you have been operated this pipe, a temporary buffer area will be created at the kernel, whatever the output of this ls-l will be forwarded to that particular buffer. Therefore, it has been taken into, I mean, more has been, more, not it is moved, more has been taken the data from this buffer. Okay. However, this pipe is a data channel which is unidirectional. Okay. So consider this is writing end in the sense. So it could be writing end in the sense, and the second side must be reading end. That's all. Okay, consider this is writing end in the sense, second side, opposite side must be reading. You cannot perform writing and reading at the same end. So that is why it is half duplex, otherwise unidirectional. Okay. Then if you want to process inter-process communication between two processes, we have to create two different types of pipes as parent and child pipes to process the data. Okay, so normally pipe cannot be taken. So left hand side, this is the parent process. For example, if you consider, so this is the parent process here. This is the child process here. Okay, a child cannot be sent data to parent as far as the original activity of pipe. Child cannot be sent data to the parent. It never happens as far as the original activity of the pipe here, because it is unidirectional. As we see, this is unidirectional. But if you want to perform that particular operation, so then you have to create two pipes. Therefore, so two-way communication channel, two-way data channel, not communication channel. Data channel will be established between one process to another. I have given some diagrams also for you. So look at this. And it could be used as standard input and output methods. What is that? STD in and STD out will be gets used by this particular pipe here. Okay. So therefore, how this could be? So these pipes are used in all POSIX systems. POSIX in the sense, I hope the full form of POSIX is known to you. I think POSIX in the sense, portable operating system extension. Okay, portable operating system interface extension. All operating systems have been follow the postulates which have been designed by POSIX only. So not exactly Windows, Unix, Linux, or whatever the operating system. So Sun Solaris or let me consider iOS. Everything will be follow the postulates given by POSIX only. Okay. So, however, so all things will be used here. Now you can consider here. Let us take into consideration of this particular diagram. Within this particular diagram, you can identify. There is FD1, which is always used to read the data. Write the data onto the pipe, and FD0, which is always used to read the data from the pipe. So here, this could be right end, this could be WN, and this could be read end. So you cannot perform reading at this end, and you cannot perform writing at this end. So that is why it is unidirectional. Okay. So general pipe will be seems in such a way. Whereas in two pipes will be gets created, it could be seems like this. Okay, this is the parent and this is the child. Two processes are there. Using one particular pipe, you have to send the data from parent to child. So conversely, you have to send the data right away from child to parent, if possible. Actually, for these kind of processes, it is not possible to get the data from child back, because it is operating system. So general fundamental commands these are. So that is why you could not get the data from child to parent here. But inter-process communication, continuously two processes have been communicated and sending messages and sending data from one process to another. So therefore, both full duplex kind of communication must be there between two processes. So we have to use pipe 1 could be used to read the data from parent and write it to child. After completion of that one, pipe 2 can be used to read the data from child and can be get back to the parent here. So we have to use two different types of pipes to perform the same kind of operation. Okay. So in this way, actually, in network programming, network, let me say CN, computer networks, you have one laboratory. So implement the pipes using inter-process communication. First program is like that only. I don't know whether you did or not in our CN course. So please check out with that particular uh, course, and you could get. If anybody wants, let me have some kind of information right through your Google, not Google, your WhatsApp group. Then I'd like to prepare one program for you, and I will send to you. You have to execute the same using Unix operating system, not with Windows or any other Unix operating system. You please execute, and it could be get something. So, however, these are pipes. First approach will be pipe. And the second approach will be, approach number 2 will be socket. So normally, if multi-user system will be there, the multi-user system is always trying to communicate or always trying to establish some connection between them. Wanted to establish connection between them, so you need to have some socket. Socket in the sense it is binding of two different types of software kind of issues. Number one is IP address. IP address. First one is IP, and second one is port number. If you bind these two into a single entity, then this entity will be called as a socket. So probably you please recall yourself while writing your online examinations of JNT Kakinada, you may see within the address bar. So, for example, 192.168.1, colon, so 8080 slash some other characters will be there. Online examination, something like that. The first combination of IP and port will be called as socket. And this particular socket is end point of one particular system, so to communicate with other system. Okay, so this could be always performed. So sending of data and receiving of data over network. Okay, so internet also internet also does have some socket programming inside it. Everything, whatever it may be. If you want to communicate with other fellow, then obviously you need to have this particular socket. Okay. And so it could be, it could also be considered that the data will be sent right away from one system to another system on the same network. Same network in the sense intranet. That is called as INTRE, not INTER, intranet. Okay, using intranet you can send the data between one system to another system. And so sockets are basically used for inter-process communication. Just before I spoke to you regarding this one, and so because of sockets, everybody will be used to communicate or share the data, the process in the sense of the program, otherwise the memory or CPU cycles or everything will be gets shared among several number of computers. So that inter-process communication will be gets happen extensively using sockets. If your system, your environment will be get satisfied with inter-process communication out there. The next approach will be file. So normally we are talking about this particular file in data record form, not a text file. So normally, as far as programming languages, files are two types. One is record-based file, and second one is ASCII-based file. ASCII-based in the sense, MS Word document, something like that, a PowerPoint presentation, what I am trying to give you at this moment. All these are ASCII-based. Record-based in the sense, database application. Okay, normally this kind of ASCII-based files cannot be used for communication. These are not supposed to take in any important role while communication is being happening between two or more people. So most probably the communication will be done on record-based systems only. Record-based systems in the sense, wanted to withdraw some money from the bank, obviously your record will be gets updated. Wanted to book a ticket in airlines, your record will be gets updated, not your ASCII file, your record will be gets updated. So something like that. If you purchase something from the corporate, let me say, any other corporate kind of stores, so So if you purchase a soap, their their what do you call, records will be so updated -1, and so on. In that way, so files are supposed to be used to not extensively, but these are also useful for so inter-process communication. Okay, then of course it is always used to store the data only. Then very important for inter-process communication, signals. While any problem will be pertained, any problem will be so pertained by the system, then it is going to generate one signal in through inter-process communication system or arrangement. So these are actually not software kind of thing. These are so actually hardware kind of thing. These are software kind of thing here. Messages will be passed from one process to another process. If you send, probably you people recall yourself from network program, sorry, networks course, thereby so piggybacking, one kind of activity is there, piggybacking. While sending data from one system to another system, if any packet is not received by another system, immediately acknowledgement will be come back. That giving acknowledgement to the previous packet is called as piggybacking. So such kind of acknowledgement or receiving or whatever it may be, some signal has been sent from one system to another system while they are trying to communicate with each other. It's called as signal. Okay, so these signals will be seems like this here. Okay, these are actually comments actually, the outputs of comments actually. Look at this. So these are the comments. So SIG signals will be always starts with SIG. PWER, power is not available. SIGINT, that is interrupt. INT in the sense interrupt. SIGHUB, hang up. Okay, signal hang up. And then SIC, so SEGB, segmentation violation. Okay, segmentation violation or segmentation has not been read properly, something like that. SIG FPE, floating point error. Okay, like this, I have given very few of them, not exactly more, very few of them. So signal ILL, that is instruction is not executed properly. Pipe is not, pipe is not writing to pipe that has no reader. Okay, you have been writing onto the pipe without having any reading. So because after 64 MB has filled, then the pipe cannot be take some more data to be done. So something like that. So these are different kinds of signals which have been generated by operating system to so many number of processes while they are in inter-process communication. Okay. Then next approach will be shared memory. Memory will be shared between or among several number of processes. So shared memory will also be comes under so inter-process communication only. Shared memory in the sense the memory can be shared or accessed by several number of processes simultaneously, concurrently. Of course, you can call it as simultaneously or concurrently or interchangeable words while you are talking something about parallel programming or concurrent programming. Okay? They're same word, same meaning. Okay. Then so so two or more processes have been communicating each other, some temporary local area or local variables will be there. They are supposed to store their values in shared memory area. So something like this. So here also all this approach will be used by all POSIX operating systems, including Windows operating system. Next one is message queuing. Okay, message queue. So don't consider the message queue in the sense whatever the messages you have sent through the WhatsApp, they are not considered as message queuing. They are considered as so the signals which have been passed from one process to another process. Whatever the signals you have been discussed here at this place, all these signals will be passed from, transferred from one system to one process to another process. This kind of operation is called as message queue. Don't consider that data will be processed through message queue. Please try to distinguish the actual message queue and this message queue. This message queue will be always trying to send the signals, what kind of errors, what kind of weather, data has been successfully received or not, are there any interrupts are available, existed while the data will be transmitted, something like that. All those things will be comes under the these message queues. And messages will be stored continuously, and they will be sent to the recipients or receivers. Okay, and of course, this has been used by many number of operating systems in interprocess communication. Okay. That followed by. Let us go ahead and review back. So first one is pipes. Approaches will be first one is pipes, and second one is sockets. Third one is piles. Fourth one is signals. Fifth one is the shared memory, and the last and final one is message queue. Okay, these are all different kinds of approaches. So you have to make two processes will be communicate successfully. Okay, then. So what are the role of synchronization in interprocess communication? While doing some kind of interprocess communication using whatever the approaches we have discussed so far, so thereby any problems or any challenges are there? Yes, there are many. Out of those challenges, how they could be rectified using synchronization. So this synchronization will be always required while inter-process communication will be happen in concurrent systems. Okay, so these will be taken care by. So this is synchronization will be provided one kind of a mechanism to control the execution pattern of two or more processes. And the synchronization could be included. Let us see semaphore, and then second one is mutual exclusion, and then reducius or barrier, something like this. Semaphore is actually olden days. In the beginning time, semaphore has been. What is the motivation for creation of the semaphore? Is Peterson solution. Peterson solution. That is the motivation for creation of this particular semaphore. And mutual exclusion. Already we have seen what is that mutual exclusion in the previous class. So one process is being executed in its critical section, no other process will be there with critical section. That is called as mutual exclusion. And then barrier. So you have to reach to that particular time bound barrier, in the sense time bound. Reach to that particular time bound. If you requested before time bound for execution of your critical section, then they are not supposed to be considered as considered to enter into the critical section. That is what about barrier. Reducius barrier will be there, and then these are all different kinds of operations which are available with us. And tomorrow, we'd like to concentrate on semaphore. On semaphore, we'd like to concentrate exclusively on semaphore. It is very big concept which is being there with you. And also, so, very good. Core CSC and concurrent and parallel processing system. So look at this. This semaphore inter-process communication is very big topic for you. Okay. Then the remaining everything is just like that. Deadlocks and deadlock prevention. These are just like that. It is very important one. Inter-process communication. Okay. Tomorrow we shall discuss on actual semaphore, then monitor, and then segmentation. All these three. Segmentation is not there, I think. Segmentation is not there. So monitors and semaphores will be taken into consideration by tomorrow. And very importantly, I'd like to concentrate